Hi again, working our way through the respiratory system. In this lecture, we'll take a look at Dalton's law and gas law and circulating partial pressures of gases. So Dalton's law, remember Boyle's law, which dealt with volume pressure being inversely related. Dalton's law says that the total pressure of a gas is just the sum of all the individual gas pressures. So in this illustration, oxygen is at 159 millimeters of mercury inside that container. That's all that's there is oxygen. And here is another container with only nitrogen, and the partial pressure of that is 593. So the total pressure is the sum of both of those. So you take the 159 plus the 593 and you get 752. Sort of an easy graphic for this idea of Dalton's law. The sum of all the individual partial pressures that make up the total. This slide, again on Dalton's law, what you need to remember is the atmospheric pressure at sea level again of 760 millimeters of mercury. That's sort of our reference starting point. And here are the major gases in the atmosphere. There's nitrogen, oxygen, a little bit of carbon dioxide, and some other gases, including water vapor, which varies, of course, depending on location. In Yakima, there's not a lot of water vapor. But you add those up and they come to 760. So that's the total. And these are the individual partial pressures. You should memorize the partial pressure of oxygen and carbon dioxide in the atmosphere. Oxygen is approximately 160 and CO2 is approximately 0.3. We'll be more interested to follow the carbon dioxide partial pressure in the blood than in the atmosphere. If you wanted to figure out what the percentage of nitrogen or oxygen was in the atmosphere, that's pretty straightforward. So what percentage of nitrogen is in the atmosphere? Well, you know that there's 760. So if you took 597, which is the partial pressure of nitrogen, and divided it by 760, you would come up with something like approximately 79%. So 79% of the atmosphere is nitrogen. Nitrogen gas. You could do the same thing with oxygen, which is 160. It's the partial pressure of oxygen in the atmosphere over 760. Do that, multiply by 100, and you come up with approximately 21%. O2. Okay. So what about when you go up in altitude? So I don't have a slide for this, but let's take a little side trip here and figure out how much oxygen there is at the top of Mount Rainier. So I'm going to pause. I want you to pause the video and get a piece of scratch paper and then come back. Maybe you have scratch paper with you, but I'll give you a moment to find some. I should have put a blank slide in here, but I didn't think about this at the time. So take a moment, get a piece of blank scratch paper, and we'll come back and calculate the amount of oxygen at the summit of Mount Rainier. Okay, you're back with some scratch paper. I'm going to go to a blank piece of paper or a blank page, and let's title this the amount of oxygen at summit of Mount Rainier. First of all, you should appreciate that there's going to be less, going higher in altitude. And Mount Rainier's summit is approximately, I forget specifically, but it's close to 14,400 feet, plus some change feet, okay, above sea level. And so I just Googled it and asked what's the atmospheric pressure at the summit of Mount Rainier, and Google came back with it being 40% less than what's at sea level. So we know that there's 760 millimeters of mercury at sea level times 40% is 40% less. So that would give us 60%. So 60% of what's at atmosphere or at sea level. So multiply that times 760, and I'm going to pause and start over here. Okay, back. So let's calculate the atmospheric or pressure at top of Mount Rainier. Well, I looked on Google and they came back and said that the atmospheric pressure at the summit of Mount Rainier is 40% less than sea level. That's an R. Equals 40% less than sea level. Therefore, it would be 60% of what is at sea level. So if we had 760 millimeters of mercury, this is 40% less than, so it would be 60% of 760 times 0.6 for 60%, and we come up with 456 millimeters mercury for the atmospheric pressure at summit. Does that make sense? Well, we know that it's going to be less than 760. So this seems pretty reasonable. It's 60% of what's left of the 760. So how much oxygen is there at the summit of Mount Rainier? Well, the percentage of oxygen is always the same regardless of altitude. So we know that O2 equals about 21%. We figured that on the previous slide. 21% which of atmosphere so our atmospheric pressure is 456 millimeters of mercury times 0.21, and we come up with a little bit of rounding to 96 millimeters mercury equals the partial pressure of oxygen at the summit. So if you ever go to the summit of Mount Rainier, you're going to be breathing less oxygen, of course. So not to make a big deal out of that, but it's you should be able to work through those types of problems. It's not complicated. Just set it up, be clear what you're doing. The percentages, the math isn't complicated. Let's get back to circulating partial pressures in the body. So in this slide, a couple of things are going on. Here's a little table that you should memorize. It's not tough. There are just a couple of numbers that you need to recognize. Well, we've already looked at the atmospheric pressure. We've already mentioned that. And so there are two gases, oxygen and carbon dioxide, of course. So in the atmosphere, there's 160 millimeters of mercury of oxygen and about 0.3. And in the alveoli, the pressure drops to 100. And in the arterial blood, it stays at 100. So they go to equilibrium. So let's just follow oxygen for a moment, and then we'll come back and look at carbon dioxide. So on the figure at the right, This is the alveoli, so these are your lungs. And if you can read the numbers, the partial pressure of O2, this is how it's written, the large P is for partial pressure of oxygen, is 100 millimeters of mercury. All the numbers are going to be in millimeters of mercury. And the atmosphere, if you can read the small numbers again, the atmospheric pressure equals 760, and the partial pressure of O2 in the atmosphere was 160. That's what we have on the table. So there's not 160 in the alveoli of the lungs, it goes to about 100. So that's in the alveoli. It goes to equilibrium in the blood. So in the blood, again, if you can read these numbers, the partial pressure of oxygen in the arterial blood is 100. Now, keep in mind that the only place oxygen or gases exchange is at capillaries. Well, that occurred at the pulmonary capillaries. And the oxygen diffused from the alveoli into the blood. So there it is at 160. It circulates through the heart. There are no capillaries in the heart. So there's no change in the partial pressures. By the way, what blood vessel is this representing? Be clear on that. So those are the pulmonary veins, returning oxygenated blood back to the heart. There's no capillaries in the heart where we're doing gas exchange, so you just continue on to the systemic circulation. What's the partial pressure of oxygen? Still 100. No capillaries, no change. Now we get to the tissues. And back to our table at the top left, at the tissues, the partial pressure of oxygen is 40. So out here in the tissues, it's about 40 millimeters of mercury. And that goes to equilibrium with the blood. So the venous blood, the systemic venous blood, is also 40. And this is the partial pressure of O2. Goes back through the right side of the heart, out through the pulmonary arteries, no capillaries, no change. So it is still partial pressure of oxygen is still about 40. Then it goes back to the lungs and picks up a fresh load and leaves as 100. So there is the venous blood. Make sure you can follow along and recreate that on your own. Carbon dioxide, once we're in the blood and once we're in the alveoli, it just fluctuates from 40 to 45. So that's not too bad. The partial pressure of carbon dioxide in the lungs is 40. So don't get all the 40s mixed up. There's two of them. We had returning partial pressure of oxygen at 40. It's just coincidental that the partial pressure of carbon dioxide in the lungs is also 40. Okay, that goes to equilibrium in the lungs. So the blood leaving the lungs is also at 40. And this is the partial pressure of CO2. No change going through the heart. So again, entering the tissues, the partial pressure of CO2 is 40. Where is carbon dioxide being generated? It's being generated in the lungs during the Krebs cycle and the other step in metabolism. And the partial pressure in the tissues is, so this says 46, I had 45. Well, let's go with the larger numbers that are easier to read. Close enough. Let's call this the partial pressure of CO2 in the tissues equals, say, 45. 45, 46, I'll take either one. Made up the table, I didn't match it to what's in the figure, and different figures show slightly different amounts. Close enough. No change in the partial pressure until we get back to the lungs. So the partial pressure of CO2 here is 45. Same with going back into the lungs. Partial pressure of CO2 equals 45. And the lungs are at 40, so carbon dioxide leaves the blood, flows down a pressure gradient back to the lungs. So what I would do is practice a stick drawing, which is the next slide. So practice doing what we just did and keep it simple. So keeping it simple might look something like this. Oops, I need a little bit of room to draw. And this would be the atmosphere. And you know that that's 760. And in the lungs, the partial pressure of oxygen is, what did we say? About, well, let's do this different. Let's draw little leader lines. So the partial pressure of oxygen in the alveoli was 100 millimeters of mercury. And the partial pressure of CO2 in the lungs was what? PCO2 was about 40 millimeters of mercury. Okay. And then here's where you should keep it simple. Let's do the lungs, sort of maybe something like this, give us a little room to draw. And if we want to keep it really simple, could just do this. And we go back to the tissues. And then that goes back to the right side of the heart. And then we go back to the lungs. And we'll call this the tissue capillaries. Oh, no, this isn't the lungs. I just drew the lungs. Sorry. These are the pulmonary capillaries. Pulmonary caps. Okay? So the blood goes to equilibrium. So in the pulmonary capillaries, the partial pressure of oxygen was 100. So the PO2 oxygen equals 100. Let's just follow the oxygen first. Keep it straight. So what's the partial pressure of oxygen in the pulmonary veins? 100. And there's no change going through the heart, through the systemic arteries now. So again, the partial pressure of oxygen is still 100. It'll stay that way until it gets to the tissue capillaries. Regardless of the level of exercise, whether you're sitting on the couch or running as hard as you can, it'll still be basically 100. What will change is at the tissue level. So going into the tissues, it's still at 100, regardless of exercise level. Barring minor changes. And at the tissues, the partial pressure of oxygen is what? It's going to be less than 100 because we're using it up. That was at 40 millimeters of mercury. It leaves, so we have partial pressure of O2 equals 40, and leaving, it's still 40, and entering the lungs, it's still 40. And then it picks up a fresh load of 100 and it leaves again. So you're just going from 100 to 40. Okay? And for carbon dioxide, the CO2 in the lungs, the partial pressure of CO2 in the lungs was, again, coincidentally, 40. No, let's make it 45. Sorry, because this is 40. So the CO2 has to go from 45 to 40. And it leaves the lungs at 40. We gave up the oxygen. Gave it to the lungs. So the partial pressure of CO2 leaving the lungs is less. It's now down to 40. And it stays that way all the way to the capillaries. Where it picks up carbon dioxide from the tissues. So the partial pressure of CO2 in the tissues was 45 millimeters of mercury. That enters the capillaries, and things are getting pretty small right in the capillaries. You can redo this. PCO2 is 45, and then leaves and stays at 45. And stays that way all the way back to the lungs. Where it then diffuses out of the lungs, where it's at 40. So the CO2 goes from low of 40, picks up CO2 at the tissues, and returns to the lungs with 45. So it just circles between 40 and 45. Okay, that's enough of that. Practice that. Get some scratch paper and ask questions when you have them. And maybe I'll talk with you during office hours, which are Monday through Thursday, starting at 9 o'clock. Monday and Thursday, 9 to 10. Tuesday, Wednesday, 9 to 9:30. So, see you soon.